This is Scott Carrick, and today we're going to be doing question 3 from 2009 AP Calc BC FRQ. This one obviously involves a parametric forms of equations. Let's get started. So number 3A, after you read the question, obviously it's a diver problem that is involving a diver jumping from a diving board. It starts off at 11.4 meters, and there's your equations for the parametrics. So in 3A, when we're trying to find the maximum vertical distance from the water surface to the diver's shoulders, obviously a keyword here is going to be maximum. So when you hear that, it's going to be involving setting this, since it says vertical as well, it's going to be setting this dy dt function equal to 0, since that will find a maximum critical point. So as you can see, dy dt is equal to 0 only at t equals 0.36735. So in order to find the actual height of which the maximum vertical distance is, you must start off with the initial value of 11.4 meters from the water. And then in order to find the actual position of where this height is, you're going to have to change that rate of change function of dy dt into an actual position function, and that is what we do here with the integral. So it's going to be the initial position plus the integral from 0 to your maximum or your critical point of your function times dt, and that's going to give you 12.061 meters. So that's your answer to 3a. So now moving on to 3b, it's going to ask us to find time A, which is the time that the diver's shoulders enter the water. So since once again, it involves initial position, so initial position is 11.4, and again, since the vertical equation is a rate of change, we're going to have to convert that to a position function using an integral. So it's going to be 11.4 plus the integral of dy dt times dt, which is going to give you the formula, or the position formula, of 11.4 plus 3.6t minus 4.9t squared. So yeah, that is the position of the diver at any given time. So in order to find out when this diver, at what specific time, hits the water, we're going to set this function equal to 0. And when it is equal to 0, t is equal to 1.936. And that will be your answer to 3b, the A time. So now moving on to 3c, it's going to be finding the total distance traveled by the diver's shoulders from the time she leaps from the platform until the time her shoulders enter the water. Alright, so this is obviously going to be distance, as you can see. So what we're going to try to do is use the length of a parametric curve formula. So to remind you guys, it's going to be the integral from a to b of the square root of dy dt squared plus the square root of dy dt squared plus dx dt squared dt. So in this problem, it's going to be the integral from 0 to the time she hits the water, because that's going to be the total length of the curve, and the square root of dy dt squared plus dx dt squared dt. And once you plug that into your calculator, since this is a calculator involved question, you will get 12.946, and that is going to be your answer to 3c. Now, like always, the last question in any FRQ is the hardest, so it's going to ask us to find the angle of theta between 0 and pi over 2, that is between the path of the diver and the water at the instant the diver's shoulders enter the water. So this was quite the challenge. So what I drew was a triangle that involves the dx dt rate of change and the dy dt rate of change. So to picture this, it would kind of be like, since the diver's path is like this would be the dy dt, and this would be the dx dt, and we're going to be looking for this angle right here. So doing that, obviously that angle, in order to find the actual angle, is going to involve a trigonometric function of tangent, because tangent is opposite over adjacent, and we know the opposite over adjacent. So here's going to be tangent theta is equal to dy dt over dx dt, and when you're dividing these, you multiply the reciprocal, and obviously you're left with just dy dx, so the rate of change of the diver's position. So since we're looking for the rate of change, like it says in the question, at the instant the diver's shoulders enter the water, then we're going to be trying to solve dy dx at t equals 1.936. So here's dy dt, 3.6 minus 9.8t, over dx dt is going to be 0.8. So at t equals 1.936, the answer to this equation is going to be negative 19.219. So you take this and you move it right here to dy dx, because that's what you solve for, and it's going to be tangent theta is equal to negative 19.219. Now, solving the problem, you're going to use an inverse tangent to separate the variable of theta, and you're going to be given theta equals arctan of negative 19.219. Solving this in your calculator once again, you're going to be getting theta equals 1.519, and that is going to be your final answer. And with that, that concludes BC 2009 question 3. Thank you very much.